I wanted to go over how to solve trigonometric integral problems of tangent and secant, odd, and even powers. Okay, so first thing you want to know are these formulas or equations. Um, so the basic one is tan squared x plus 1 is equal to secant squared x. We will manipulate this to fit our needs if necessary. But the main thing that you guys want to start off with is in the beginning of the problem, right? If you see your secant has an even exponent, you're going to try to make u equal to tan. If your secant has an odd exponent, you're going to try to make secant equal to u. You'll learn more, you understand more what this means as we go through problems right now, okay? So let's start with the first problem. All right, so the question is asking us what is the indefinite integral of tangent x to the sixth power multiplied by secant x to the fourth power dx. So what do we want to do? All right. So we know we have an even secant, even number in our secant, right? Even exponent of secant, see the 4. So we know that we're going to make u equal to tangent. So let's try to do that. Um, First thing I'm going to do is try to break the 4 down to secant squared x. Because remember, the derivative of u is going to be secant squared. So we know we're going to need 1 secant squared to count something out, right? Second thing to do now is see what we can do, right? So if I make u equal to tangent right now, I know I can cancel 1 secant squared x out, but there still would be another secant squared left because there's 2 of them. So I need to manipulate this even further. So how to manipulate this? Secant squared is equal to tangent squared plus 1. So I just replace 1 of the secant squared with tangent squared plus 1. What do I mean? Remember there's an exponent on this, so that means we're multiplying secant squared by 2. I just use one of the secant squared x's and I input it tan squared plus 1, right? So let's see. We have an even exponent and we know that our u is going to be equal to tangent. We took care of the previous problem of having that extra secant squared x left over. Can we do u substitution right now? And the answer is yes. Yes, we can. So let's make everything in u. Our u is equal to tan x, our du is secant squared x dx, and our dx is du divided by secant squared x. Let's do some algebraic manipulation. So we have our u6, u squared plus 1, and then we can cancel out our secant squared because we did the u substitution. Now what we're left over is going to be u6 times u squared plus 1. We would just distribute the u6 in the parentheses, and we will get u8 u to the 8th power plus u to the 6th power du. What's the next step? Basic integration, and that'll make us have u to the 9 plus u to the 7 divided by 7 plus c. So what's the last step? Just plug in our u. What was our u? It was tangent. So now the final answer is going to be tangent to the 9th x divided by 9 plus tangent to 7x divided by 7 plus c. And here's the full answer. So the indefinite integral of tangent to the 6th power x multiplied by secant to the 4th power x dx is equal to tangent to the 9th power x divided by 9 plus tangent to the 7th power x divided by 7 plus c.